So, what happens when your startup suddenly goes viral, but your entire company is running on a server with less power than the phone in your pocket? Today, we're going to break down the incredible true story of how the e-commerce platform Dukaan scaled from a complete system meltdown to handling millions of users. And they did it all by thinking of their servers as a single overworked chef in a tiny kitchen. It all kicked off with a 3 a.m. phone call.
It all started with that phone call. You know, the kind that jolts you awake at 3 a.m. with a shot of pure adrenaline? This was Dukaan's co-founder on the line with his CTO. The company wasn't just having a problem, it was experiencing a complete and total blackout. The site was down, the app was throwing errors, everything was on fire.
And after a frantic investigation, they found the cause. And honestly, it was kind of embarrassing. The entire company, we're talking thousands of businesses, millions of products, was running on a server with just 512 megabytes of RAM. To put that in perspective, your smartphone right now probably has 16 times that much. They had tried to host a rock concert in a telephone booth, and the booth had finally spectacularly collapsed.
Okay, to really get how they fix this, we need to understand what a server actually is. And the best way to do that is to just forget all the technical jargon for a second. Just think of a server as a restaurant kitchen with one single, very, very busy chef. This one analogy, it's the key to everything that follows.
This simple table right here is the key to the whole thing. The CPU? That's the chef's speed. The disk? That's the pantry where you store everything. But the most critical part of this puzzle was the RAM, the countertop, the working space for all the current tasks. And as Dukaan was about to find out, their countertop was barely the size of a cutting board.
So here's exactly what was going on. Their app and their database were both fighting for space on that tiny little countertop. Imagine the chef trying to cook the app's code while also constantly having to run to the pantry for the database, all while new orders are just piling up. The result? Total and complete gridlock.
The solution was, in theory, pretty simple, but in practice, absolutely terrifying. They needed to give the database its own dedicated room. It was time for what they called the Great Divorce, moving the database to a completely separate server. You give the chef his own kitchen and the database its own library.
Now, performing this divorce meant doing open-art surgery on a live application. They had to create a perfect clone of the database, transfer it over, and then, with the site down for just 3 nail-biting minutes, flick a switch to point the application to its new home. The stakes were just incredibly high. One little mistake could corrupt all of their data, forever.
And guess what? The surgery was a success. The site was faster, it was way more stable. But in the world of scaling, every solution just reveals the next bottleneck. With the database humming along happily in its own library, the pressure was now entirely on the single application server. That one chef in the kitchen, he was about to get completely overwhelmed.
And this brilliantly illustrates the two paths they could take. They could scale up by just replacing their server with one giant, expensive super chef machine. Or they could scale out by hiring a whole team of identical, cheaper chefs. Now, scaling out is more complex, for sure, but it's fault-tolerant and it is the only real long-term path to massive scale.
So if you're going to hire a whole team of chefs, you need a manager to distribute the orders, right? Well, in the server world, that manager is called a load balancer. Just think of it as the digital traffic cop, sitting right in front of your whole fleet of servers and directing the flow of users.
The load balancer's only job is to look at all the incoming traffic and intelligently send each user to the server that's currently the least busy. This is what prevents any one server from getting totally overwhelmed, while the others are just sitting around doing nothing. It's what makes a whole fleet of servers work together as one single powerful unit.
But you remember the golden rule, right? The bottleneck always moves. Now, with a whole team of application servers all cooking at full speed, they were all running to the same library for ingredients. Their single database server, that heroic librarian, was now being hit with requests from an entire army of chefs. Yeah, it was starting to sweat.
So how do you scale a single database? You can't just clone it. That would create total chaos. The team realized they needed to get smarter. They needed a bouncer for their database, someone to separate two very different kinds of requests, updating data and just looking at data. And when they analyzed their traffic, they found this staggering imbalance. A whopping 95% of their database work was from customers just browsing stores. These are called read queries. Only 5% was from sellers actually updating their products, the write queries. The huge crowd of people who were just looking was blocking the important work of the writers.
This led to the next brilliant architectural leap: read replicas. They kept their original master database, which would now act like an exclusive VIP club, handling only the important write operations. And then they created perfect copies, the replicas, to act as the main dance floor, absorbing the massive load of read traffic from all the casual browsers.
But this created a new and kind of spooky problem. The data stream from the master to the replicas is fast, but it's not instantaneous. There's this tiny delay called replication lag. This meant a seller could update a price, immediately refresh her store, and for a split second, still see the old price. It was like seeing the ghost of her old data.
So this led to a very conscious trade-off. They embraced a concept called eventual consistency, sacrificing the guarantee of instant updates across the entire system for the ability to handle millions of users. The system promises that all the copies will eventually be the same, just not right away.
This whole journey, it just reveals a fundamental truth about building technology at scale. It's not a destination, it's a ladder. Every single problem you solve just lets you climb high enough to see the next one. The bottleneck never truly goes away.
The lessons from Dukaan's story are universal for anyone building anything. Your first architecture will fail. Every fix introduces a new challenge. You're in a constant game of whack-a-mole where the bottleneck just shifts from one part of your system to another. The real key is to start simple and be ready to evolve.
And that brings us to the final, and maybe the most critical question. This entire journey was about scaling technology to handle load, but as a startup grows, there's a much, much harder challenge. It's not just about servers anymore, it's about people. So have you scaled the processes and the culture to prevent your own team from becoming the next bottleneck?